instructions on this example say to graph the function and then tell it whether its inverse is a function. And then there's a follow-up to graph the inverse. So we have f of x equals 1/2 x cubed and a table of values to help us graph this function. So we'll just plug in values for x. You know, we could do our -2, -1, 0, 1, 2, and get these points. So if we have a -2, so -2 cubed is a -8 times 1/2 is a -4 for our first point. Our next point, if we plug in a -1, so 1/2 times -1 cubed. -1 cubed is -1 times 1/2 is a -1/2. You plug in 0, we're going to get back a 0. The next one, we plug in a 1 for x and cube it. Well, 1 cubed is 1 times 1/2 is just 1/2. And then our last one is a 2. Plug in 2 for x, so 1/2 times 2 cubed. 2 cubed is 8. Half of 8 is 4. So, graph the function. We can graph the function now. We have a set of values. So -2, -4, -1, -1/2, 0, 0, 1, positive 1/2, and 2, positive 4. So our function looks like this. Now the next, so we did the first part. The next part says, tell whether the inverse is a function. Well, we're not looking at the inverse, so how can we tell by looking at the actual function to see if the inverse will be a function also? So this is that horizontal line test that we talked about in class. So we want to do the horizontal line test on the function to see if the inverse will be a function. So that means if we draw a horizontal line anywhere through the graph, we only want it to cross in one spot. So as we can see, our horizontal line is crossing through our graph only in one spot everywhere along here. So it passes the horizontal line test. Now, when it passes it, that means that our inverse is a function. So tell whether the inverse is a function. Yes, it is because it passed the horizontal line test. Then the next part says, graph the inverse. Well, we could switch the x and y, solve for y, do another table of values, or since we already have this nice table of values right here, we can graph the inverse just by switching the x and the y coordinates. So instead of a -2, -4, it's going to be a -4, -2, a -1/2, -1, 0, 0, 1/2, 1, and 4, 2 for our x's and our y's. So I come over here, we graph -4, -2, -1, or -1, I'm looking at the wrong numbers, -1/2, -1, which is right here, 0, 0 stayed the same, 1/2, +1, and then 4 and 2. And now we can see that our graph is looking like this. So if we look at only the pink one and think about a vertical line going through only the pink one, you know, if I were to move the purple one for a second, that's the inverse, and we can tell that it is a function because it would pass the vertical line test. So when we can see it, it should pass the vertical line test. When we can't see it, when we can't see the inverse, do the horizontal line test on the function to see if the inverse is a function. Now, one thing I just want to point out real quickly, if you remember, we talked about an inverse function. It takes our function and reflects it across this line y equals x. So you can see the purple one, if you take every point, you know, and reflect it across, you know, we're getting its inverse. So it looks good because it's a reflection across, I mean, it looks like we graphed it correctly. It's a reflection across that line y equals x.